everyone, it's Emma back with another video for Chemistry GCSE, and today we're going to look at covalent bonding. So we've already done ionic bonding and now we're going to look at covalent. I hope I'm spelling that right. I don't know, is it lant? Oh yeah, I spelt it right. Okay, so covalent bonding, two rules. It's when electrons are shared between atoms, and it happens only in non-metals. So you just got to make sure that you check your staircase if you're not sure if things are metals or non-metals. Like lithium, that's a metal. I don't know if you would know that. It's not going to ask things like iron, because that's in the middle section here in the transition. But you know, use a periodic table to double check whether things are metals and non-metals, and always remember that this hydrogen at the top is a non-metal. So it has to happen between, it happens between non-metals, so we don't have ions here. And all the non-metals have actually, they're generally, in groups 6 and 7, they all want electrons. So let's say oxygen, for instance. Oxygen is in group 6. It has 2 electrons in its outer shell, like so. I'll make it look like a boob now, probably. Oh, that's oxygen. Let's say it wants another 2 electrons, doesn't it, to get the full outer shell. It bumps into another oxygen, and because I'm comparing them to each other, one gets crosses, one gets dots. Now, these 2 oxygens are both desperate for the full outer shell. Sorry about that. These 2 oxygens are both desperate for the full outer shell. They both need 2 electrons, but none of them can afford to give any up. So what they think is, well, if I share 2 with you, will you share 2 with me? And that's what happens. So these 2 oxygens bump into each other. They can't give away, so they both share. And your picture should be a bit better than that. I'll draw it again. If you had to draw the bond between 2 oxygens, or the bond that happens between oxygens, they're the O's in the middle. So oxygen 1, let's say this is oxygen 1, you don't need to label them as 1 and 2, but oxygen 1, oxygen 2. Oxygen 1 puts 2 of its electrons in the kitty in the middle. So it's put 2 in the middle, it's got 6 altogether in the outer shell. So 1, 2, and now we're going to use the remaining 4 to go around its shell. So these 4 will just carry on going around the oxygen it belongs, but these 2 in the middle will go around both. So both atoms, both oxygens, will feel that they own them. They do it very equally. So if this oxygen, number 1, has put 2 into the kitty, so will oxygen number 2. And now they are sharing 2 pairs of electrons. We don't say they're sharing 4, we say they're sharing 2 pairs of electrons. So oxygen 2 has put 2 in the middle out of its 6, so it has another 4 that go in its shell. And that is it. That is the bond, that is a covalent bond between 2 oxygens, and it becomes O2. And that is what O2 is. I'm going to look at another one. I'm not very good at preparing. Let's do a simple one. Hydrogen. Hydrogen is in group 1. It's got 1 electron in its outer shell. Imagine if it bumps into another hydrogen, also in group 1. Now, it's only hydrogen and helium that need 2, well, helium's already got the 2, but it's only hydrogen that needs 2 electrons to fill that outer shell, because it's only got the first shell to fill. So they do exactly the same as what the oxygens did. However, they only need to share 1 pair, don't they? So hydrogen 1 puts it in the middle, hydrogen 2 puts it in the middle. And there's no more to use, because they only own 1 each. I go a bit more complicated now. Describe or draw the bonding between, that forms H2O. So this is H2O. H2O, so the 2 follows the H, which means there's 2 hydrogen and there's 1 oxygen. Whatever's in the odd thing goes in the middle. So if you've got 2 hydrogen and 1 oxygen, the odd thing is the oxygen. Because there's 3 atoms involved this time, we draw 3 circles like so. The odd one goes in the middle, which is the O, the boob looking one again. And they are our circles. So oxygen, if you can remember, or you can find it on the periodic table, is in group 6. And these hydrogens are both in group 1. So this one's in group 6, these are in group 1. That means that the 2 hydrogen have 1 electron in their outer shell, and the oxygen has 6 electrons in its outer shell. So this hydrogen here can only put 1 in the middle for oxygen. Oxygen does the same back, so I'm going to represent oxygen with my dots. All right? There's no more for the hydrogen to use because it only owned 1. Let's look at sharing this side now. This hydrogen can also donate 1 into the kitty for them to share. Oxygen will do the same. So oxygen is actually sharing 1 pair with this hydrogen, and it's sharing 1 pair with the other hydrogen. I said that the oxygens were dots in this case. So we've represented 2 of them. Now a lot of people got 1, 2, 3, 4, oh, 5, 6. No, we've only represented 2 of them so far. 1, 2. So oxygen, this way, if it's a 3-mark question, this way you get the last mark. Or 2 marks really. You've got to show where the remaining electrons that aren't being shared are. And that is the bond between H2O. Do 1 more. Notice that all these are gases or liquids. So these covalent bonds, we call them simple molecules. They have very low boiling and melting points, which means generally at room temperature, they are a liquid or a gas. Last one, show the bonding that happens between or in CH4. This is methane, but I'm sure it would tell you really. It doesn't expect you to know methane for anything. So carbon is a non-metal, hydrogen is a non-metal. So you know, oh, it's not ionic, it's covalent because they're non-metals. There is 1 carbon because there's no number after it. And there are how many hydrogens? 4. So in this case, carbon is the odd one out. So we'll put carbon in the middle. And because there's another 4, we'll just wrap them around like so. Label them carbon, hydrogen, 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 hydrogen. Okay, we're nearly there straight away. All these hydrogens are in group 1. So they have 1 spare electron. So they'll all donate them into the kitty, give them crosses. Carbon will do the same. Carbon is in group 4. So it's going to donate 4 individual ones to each of the hydrogen. So it's all of the outer electrons in the outer shell have been used up, and that is now the bond for CH4. So make sure that the circles overlap. Make sure that you account for, sort out the electrons that are being shared first, and then check whether they've got any extras to use up. And yeah, nice question. If you can get your head around it, you can apply it to so many questions. And that's it for this video. Thanks for watching. I'll speak to you soon.